In this part of the lecture, we will present the functional tree diagram and the components, the main components of the data flow diagram. Why we present these two diagrams together? Because they are related. Both of them are related to the functions of the system, how we treat data. DFD is standard, but functional tree, it is not as familiar as DFD. We don't have source to define the standards of a functional tree. What is functional tree? It is very simple tree. Usually it is from top to down. The root is in the top, and we have many lines to indicate. For each node we have many branches, and from each branch we have also many branches. All the system is represented in the root as one node, and the main functions of the system are represented in the first level, and we give a number for this level. We give number 1, 2, 3. We start from the left to the right, and for each function we have a sub-function. For example, for sub-function 1, we have to the left in the lower level we have sub-function, so we'll give it the number 1.1. So the child inherits the number of his parent, and we add point and the specific number of the child. This diagram is very simple, but it is very important to have an idea about the global system. What is very important, these are not parts of the system. There is two important notices. One of them is the node are functions, the other is the lower level is sub-function, so it is not a different function. So for example, sub-function 1, it should be included in the system. As we said, we focus mainly in the functions themselves, not in the component of the system. So if in this such diagrams, if we say, for example, student, it's not correct. Perhaps learning, teaching, etc. It is a function. The goal is not to focus on the actor, so we don't know from this function who make the action. We don't know from these diagrams where the function takes place and when it happens. As I said, it matches very well with DFD. How we represent it? It is a rectangle. Each rectangle, it is a function. The root, that means all the system. Each function can be broken down into several sub-functions, so it is advised to be between 3 to 6. Why? To facilitate the understanding, because if we put less than 3, if we put 2, it is not really very logic to break down one node into only 2 nodes. Sometimes it may be done. It is not forbidden, but it is not very common. And from the other side, if we have more than 6 operations, that means there is a problem, because we cannot understand the relationship between this component, between this function and the sub-function. Instead, we can make this separation in 2 levels. As we said, regarding the child number, it includes the parents number. What is very important, functions names are expressed in infinitive or as a system. It is from the system point of view. So if I say in a school, I cannot say that the school is learning, but school is teaching. So it is from the point of view of the system. The another thing is infinitive. When I represent the school, I will not, in these diagrams, I will not say there is teacher, but I will say that is teaching. There is a function, there is operation. We should define really these type of functions. Now we go to data flow diagrams. As functional tree, we focus mainly on the flow of data processing the system. So we can see how data enter the operation, how it is processed, and what is the output of this operation, what is the output of these functions. So we distinct data flows. It is an arrow. Data flows from the environment to the system. So we can see what enter into all the system, what are the output of all the system, the data flows in the system, what happened in the system, data flows from the system to the environment, the internal process that treat data in the system. So we can have an idea about all the processes in the system where data information are stored in the system. It is very simple because we have only 4 elements in the data flow diagrams. It is the external entity. These external entities are out of the system. They send data to the system and they receive data from the system. There is the arrow that represents the data, the movement of data. And there is the process that represents the function, the activity in the system, and it is the data store. What type of data store we have? It is not how data are stored. It is very important. This is the familiar representation of the elements of DFD, but sometimes we have some different representation. For example, if we don't put shadow to the rectangle to represent the external entity, it is not really a problem. We have another representation of the process. For example, we can represent it as a circle. So the activity of a process, it may be represented by one of these forms. We can see to the left the most famous one, in which we can put the name of the function and the number, because DFD correlate all the process together. We saw, for this reason, we presented at first the functional tree. What is a process? It is an activity within the system that receives and treats and produces data. So it should do something for the data. The process should change the form of data. It has a name and a number, usually. Usually the name in the infinitive or name of system or subsystem, or which group together several activities. So the name, it should be a clear activity, or it may group many activities together. We don't see how it comes through. So we don't know about, from the DFD, we cannot know about the realization of these activities. The third representation, the third form, is not very famous, but sometimes we see it. And here we present the place. This is not really correlated with the goal of the DFD. In DFD, we can say that we have many levels of DFD. We have logic level, conceptual level, and we have physical level. When we talk about physical level, we talk more about the realization of the system, and sometimes some people use precise the place or the domain of the application of the process or function. The second element of data flow diagrams is a data store. What is a data store? It is a store of data in the system. For example, if we are in a school, we know that we have somewhere a store for the names of students, for the name of the professors, for the marks of students. This form, this element is represented as an open rectangle, and sometimes we put, most of time we put a number, and most of time this number starts with letter D and with number D1 D2, that means data store 1, data store 2, data store, and we put in the other part the name. Usually these data stores are realized by electronic or non-electronic methods. They may be assembled papers. They may be archives, they may be tables, they may be files, databases, etc. And most of the time the name is plural. That because the database have, for example, when we have an archive for students, we have students because we have a lot of students. But when we have the data flow, most of the time the data flow is single, the data store is plural. Usually it has a number, but before the number we have the letter D, D1, D2, D3, etc. We should pay attention that the data store cannot modify itself the data. It is merely storing tool. So what we put in the archive, what we put in the data store, it is the same data that we will get out of the data store. To facilitate organization and understanding of the diagram, the same store can be repeated several times. In many times we have a very complex diagrams for the DFDs. For this reason we can separate the diagrams and we can represent the data store many times in many pages, for example, of the diagrams, but we should keep the name, the same number and the same name. The external entity, it represents the entity with which the system cooperates. This entity may be a human, it be an automatic system, it may be an official entity, it may be a social structure, it may be an enterprise, so it depends. But it is something that is out of the system, and we have, it is in our environment, it is in the environment of the system, and we have some communication. We receive data from this entity, or we send data to this entity. To represent the component of the environment that send data to the system or receive its information. Most of the time it is rectangle, sometimes with shadow. It is shaded. It represents another department, company, person, or machine. The data flow, it is merely an arrow, oriented arrow with the name of the data. Always for the data flow there is source and destination. Source and destination may be the process, may be the external entity, may be the data store. But we should pay attention, we should not have a data flow between two external entities because we are in the system. The name is usually in the singular. It does not show the time or the frequency of the flow. So we try to make a general name for the flow. It is the same for the process and for the internal entities and for the data stores. This is an example. We presented in the previous video an example about the connected home. So what is connected? To simplify, we will not represent everything in the connected home. We will present here in this example the higher level. All the system will be represented by only one process. So what we can receive in the connected home, we have many. So here in our system connect with the indoor environments. He get a parameter about the temperature, the humidity. He communicate with the network services of the house, with the meters, electrical meter, water meter. He can read the consumption index. and he communicate with the doors, with the objects in the house, in the apartment, and he can know the situation, if it is open, if it is closed, so he can know the state. Also, he can communicate with an inhabitant and with a researcher, because the type of communication is not the same. But to facilitate the example, we will not go in the details of these external entities. Also, we can say that it communicates with the central database. So it depends. Now, when we represent the systems, it depends our imagination about the system, about the limit of the system. Is the sensor, for example, is a part of this system, or is not? It is not a part of this system. We concentrate on the computer, on the Raspberry Pi, or we concentrate on all the hardware parts on our system. Is the researcher is a part of our system or not? Is the inhabitant is a part of our system or not? Do we talk about a local system in the level of one apartment, one residence, or we talk about a neighborhood, or we talk about a complete city?